Hey Pixelers, Michael Haddon here. So I had a client last week ask me, what should a startup do for disaster recovery? And he was asking me lots of these questions about theory, which you can find on the AWS blog website, which gets into all of the complicated stuff which enterprise companies do for disaster recovery. So I thought it'd be nice to do a video where from like A to Z, we talk about all of the great strategies you can do for disaster recovery depending on the size of your organization. The things you should tackle first when you're a startup, all the way to explaining how enterprise does it, because I've managed these types of things for startups to enterprise and implemented all of the strategies I'll talk to you today in various different organizations. Now, usually when you go online and you research disaster recovery techniques, you'll usually find, like I said, all of the enterprise approaches. But the problem with this is fundamentally all of the enterprise approaches usually assume you've done all of this stuff up here already, and they take it for granted that you've done this stuff already. And so it can feel a bit overwhelming when you're a smaller company thinking, oh, I already have to implement pilot lights already, right? That's the first stage, right? As a startup, that's the first thing I got to do. When in fact, this is all the stuff you should be focusing on to begin with, right? And so you can imagine this as a chain that goes from startups all the way around to enterprise like that. So we're going to go through the whole chain and you're going to be able to see where you currently fit on this maturity line and what your next stages should be if you want to improve your current situation. So the first stage is praying, because this means you don't really have a disaster recovery strategy. So what is disaster recovery? Well, disaster recovery is the process your organization takes to be able to recover from an incident. What Google says quite often in its SRE book is hope is not a strategy. It's kind of like how with Sod's Law or Murphy's Law in America, everything that can go wrong will go wrong. So the assumption that our system will stay safe and stable forever is foolish at best. There will be an incident that will bring your system down, and if you're just hoping that nothing bad happens, you're doomed from the beginning. This is when you hear stories of companies being knocked out, potentially for months, as they need to rebuild their system from scratch. And usually these types of events end up leading to the bankruptcy of the organization. So hope is not a strategy. Now, what this fundamentally means is you need to have stuff in place before you ever take a new application or system into production. That means having runbooks in place, having your backup and restore processes in place, and everything we're going to talk about further on, making sure you have all your processes in place so people know how to act inside of the organization. You need to do all of these things and apply best practices before you go to production. So the first stage is backup and restore, and this has a bit more to it than you might think. Now, a backup is only as good as your test process for the backup. So you always need to make sure that when you're actually doing a backup, you are testing that backup. The frequency that you do test the backups does come down to what sort of compliance requirements you have and the amount you can invest into this. But it's normal for companies to at least have quarterly or even monthly backup tests to be able to make sure that their system is stable. When you get to the more enterprise setups, you usually want to make this an automated process which is happening continuously. Whenever you do anything like this, whenever you have anything which is highly critical, you always need to make sure the processes are in place in order to manage this. You never know when that person who knows how it works is sick or unavailable or alternatively leaves the organization. And so you do need to have runbooks in place so other people can pick up the work, or alternatively, even the same person who does the work all the time is able to continue to repeat the process of doing the work without making a mistake in the future by forgetting to do something or doing something in the wrong order. So it's very important that you do have your processes down for your backup and restore procedure. That may sound good, just do a backup, but there's some good practices when it comes to backups that are worth knowing. For example, the first one is use idiomatic backups. An idiomatic backup is using the backup method that the tool itself recommends, right? So this doesn't necessarily mean backing up your database by just doing a copy of the files from one location to the other. You should ideally be using the official backup tool or the widely recommended tool or the industry standard tool in order to do the backup and restore process. You should never be thinking, how can I do this myself? Because then you're likely to find that your system may have problems restoring, may have problems doing its backups, and then you end up in a situation where you thought you had nice stable backups for 6 months in a row, and then you find out you can't restore any of them when you do run into an incident, and therefore causing your whole organization to grind to a halt. You're far more likely to find your data getting corrupted when you come up with your own solution. Now, the next thing is atomic backups, right? This is also extremely important and is something people often overlook. An atomic backup is like when you work with databases, things are transactional, meaning that the whole backup is the complete state of the system in one specific moment of time. The reason why this is so important and why so many people overlook it is if you just do a backup of, like I said, copying files or something like this, you're going to be in a situation where the first file copied and the last file copied are in different states of time, right? They exist in a different part of space-time continuum, meaning that they may be incompatible with each other, or have references to pieces of data which don't exist anymore or haven't existed yet, right? So an atomic backup means that at a very particular point of time, you have a complete snapshot of the system. It's a transactional backup. Usually this means using the idiomatic backup solution, as they usually take this into account, but it's extremely important your backups are atomic, or otherwise you're very likely to have corrupted backups. Now let's talk about some good practices when it comes to backups, and that brings us to a third stage, and that's a 3-2-1 backup, because just having a backup is still a vulnerable place to be. Because what if that backup becomes unavailable just like your system does? Let's say I'm backing up my system to another point of the same hard drive, and the hard drive fails, I've lost the backup and the live system, is worthless. So we need to have a good strategy when it comes to backups, and usually the recommended way is what we call 3-2-1 backups. That means you want to have 3 copies of your data in addition to the live system. You want to have the data on 2 different media types, so if one media type fails or any problem comes up with that, you're still available, and you want to have 1 offsite copy somewhere else far away, so if you have an issue with that specific location in the world, like for example, a data center catches on fire, you've still got all of your data. Now, some companies like to take this one step further, and honestly, you should. And the thing that differs this from the previous one I mentioned is you want to have 1 copy of that data in either an air-gapped environment or an immutable setup. And then you want the 0 references the fact that you never get any error when you do your backup, restores, and tests. The immutable part is extremely important, especially in today's age, is it helps protect you against ransomware attacks. Because one of the things ransomware attacks love to do now is to go target your place that you store your backups to. And this can be a lot more common than you think it is, because usually your live system has the credentials to be able to save data to the backup location or something to that effect. And so once they compromise your live system, they're usually often able to expand their attack into your backups and encrypt all of that stuff as well. So you want to have a copy of that data either in an air-gapped environment, which isn't my preferred way of doing it. My preferred way is having it immutable. And what that means is you can only create files in that location and not overwrite existing files. And if this ever does happen to you, never pay the ransom, always contact law enforcement. You can be surprised sometimes that law enforcement may actually have a method of decrypting the files for you. I know the FBI is actually meant to be very good at this. Now, the fourth method is infrastructure as code, and you might think, okay, this is a bit strange being on this list. Why would infrastructure as code be a good disaster recovery strategy? And the reason is because obviously if you're not using infrastructure as code, you're also having to back up the servers, the literal configuration files, and the whole setup of the servers that are running your system. And if you lose those configurations, you're then going to have to go through the arduous task of rebuilding your systems manually. If you're using infrastructure as code, you can rebuild your systems automatically when there's some sort of problem or incident on the fly. And to be able to do anything more sophisticated past this point, you need to implement this stage. This is a prerequisite for everything further on. Now, there's loads of tools to choose between. There's Ansible, Puppet, CloudFormation, AWS SDK, Kubernetes, Terraform. There's far more than this. My favorite are Kubernetes and Terraform, which you'll see me make a lot of videos about. Now, in order to do this stage properly, what this means is having everything in infrastructure as code. You shouldn't be doing any clickety-clack and configuring things in your browser for your cloud environment or whatever it is that you're using. You need to be doing everything in code. And so while you might have, say, a test environment for learning the environment that you're deploying to, you should always, for production and subsequently the staging environment and maybe even the development environment, always have them fully managed in code. No change goes to these environments manually. Everything is automated. And that includes, say, things like your persistency layer. I see a lot of people thinking you don't want to manage your persistency layer, like your databases in infrastructure as code, because they get concerned, that could cause data loss. No, everything should be in infrastructure as code. Now, my next recommendation might upset a few startups, but it's to get in bed with the big cloud providers. And that may shock you because you might be thinking, well, wait a minute, why would I do that when it's so much cheaper just renting a virtual machine from some random hosting provider, or alternatively, buying my own hardware to do the hosting for it, right? And the thing to remember right now is I'm not saying as a startup you should be doing all of these things. You know, if we go back to the beginning, you'll see that these are a line of maturity, right? So we go up the line of maturity for startup, and then we go up the line of maturity for enterprise. And it could be for some startups, this is the point you stop and you wait a moment until you start growing and actually generating enough cash revenue to justify. However, the thing about maturity is understanding why it's so important to be spending the money. And the simple fact of the matter is the big cloud providers have a lot of very intelligent people managing their systems, and they're able to give you enterprise-like disaster recovery while not costing you the types of money it would cost you in order to do it for yourself. If you wanted to have a fully distributed setup and be synchronizing data from one system to the other and have no downtime and be very resilient, you're going to need to invest the money to do that, and the expertise and the time. If you're just going to want to have something which is going to allow your startup to be competitive and to have a good disaster recovery strategy, the best thing you can do is just get in bed with the big cloud providers. They're going to make it so much easier for you to actually implement these things. At the end of the day, your business is doing whatever your business is doing, and you're not an infrastructure management organization. Now, I realize this will annoy some people, but the fact of the matter is if you're an organization who understands the cost of downtime, it's better to have someone else manage that for you. So how do they make it so much easier? So in this example here, we have all of our data in one cloud provider, and we have things on what we call availability zones. So what that means is that your system is being stored on multiple data centers in the same area. So if we're talking about AWS, an example would be in Ireland, and you could have your data on 2 different data centers in Ireland. If one data center catches fire, you're completely fine. And the way that it works is you'll have your ingress, which is managed by the cloud provider, which is made to be distributed across multiple availability zones and potentially regions. That goes to a load balancer, which is managed by the cloud provider, which once again is being managed across multiple availability zones and regions for you, and to distribute the traffic between both sides, right? And the cool thing is usually these cloud providers also offer a nice managed database solution, which is also automatically resilient across multiple availability zones too. So this is all managed for you. You don't have to understand the complexity of the setup or even implement it for the most part yourself, other than saying, I want my application running on that availability zone and that availability zone. And so, for example, let's say one availability zone dies, right? Maybe literally one of the data centers in AWS Ireland or Google Cloud Netherlands or whatever literally just catches fire. Your application is still going to run perfectly fine, so much so that there might not even be a single bit of downtime in the whole situation because it's all managed for you by the cloud provider. Now, obviously, this comes with a bit of a premium cost compared to the stuff we talked about before, especially if you're paying for some cheaper hosting provider, for example, like Hetzner or whatever. But the fact of the matter is you can get enterprise-like. Now, I'm not going to say it's as good as enterprise because you're going to see how far we can take this when we start talking about enterprise. But enterprise-like availability while not actually breaking the bank. And fundamentally, as a startup, I think this is the most sophisticated disaster recovery solution you should actually bother to implement. You should only go on to the next stage, which, like I said, you see on all of the architectural examples and diagrams, once you've grown your company into more of a scale-up or start entering the world of enterprise yourself. So this is completing the maturity model of disaster recovery for startups. And usually you'll find that the disaster recovery stuff for startups focuses on rebuilding and being process-driven. Whereas for enterprise, we're going to get into a lot of more complicated topics, such as active-passive, active-active, RPO and RTO, because enterprises tend to be a lot more metric-driven. Things tend to have to go to a board meeting to get approval. So it tends to have to be documents that are proposed in order to justify an expense. We're a lot more redundant, and they're always, whenever you're dealing with anything that we're going to bring up, there has to be a business impact analysis, because enterprises, they tend to be a lot slower to make decisions because every decision they make tends to have huge volumes of money behind it. And what you'll see here is you'll find that the difference between startup and enterprise starts to become a bit more obvious. Startups are usually looking for things that allow them to stay more agile and therefore looking for cheaper solutions. Whereas usually for enterprise, the cost doesn't matter so much because they're dealing with huge volumes of money anyway, and so they have much higher availability requirements. Startups tend to be looking for cost-efficient solutions that allow them to focus on their core business. Whereas enterprise usually has dedicated teams to meet regulatory compliance requirements, which usually requires a robust multi-leveled approach. It could be that this point may already meet the requirements of an enterprise organization, depending on what it is they actually do. So how do you actually define that, right? So enterprise likes to use these two terminologies, RPO and RTO. RPO is your recovery point objective, and RTO is your recovery time objective. And let's say you have a disaster in a minute. The way that this diagram works is you have 1 hour going this way and 1 hour going that way. And the reason is everything on this side of the disaster is in the past, and everything on this side of the disaster is in the future. When there's a disaster, you might have your last usable backup all the way back here at the beginning. And so our RPO would actually be the frequency that we do the backups because it's the objective. While the backup might be 20 minutes ago, it could be that we're creating a backup every 30 minutes, right? So our RPO would be 30 minutes. 30 minutes, when you think about it, could be quite a lot of data, right? And it could be that depending on your organization and your recovery time, this could go down to 10 minutes to 5 minutes to whatever. And your RTO is the time from the incident that you're able to restore functionality of the system. And so when we define our RTO, what we're basically saying is this is what the organization considers to be an acceptable amount of downtime. Obviously, the preferred amount of downtime is 0, but 0 has the highest cost to it. When an organization does its cost analysis and understands the cost to have this number lower is so much more, that this is the acceptable amount of downtime, because that's when the cost calculation makes sense, right? And we'll get to that in a moment of how you do that calculation. Now, when we're talking about RPO and RTO, usually a few questions come up. For example, how much data can you afford to recreate or lose? And how quickly can you recover? And fundamentally, what is the cost of downtime to your organization? Not all enterprise companies come into this discussion the same. You tend to find that online shops like Amazon tend to have a more critical understanding of downtime than things which are, let's say, government funded or institutional, because if a customer isn't able to do something in a certain period of time, it doesn't necessarily mean that they won't do it when the system comes back online, right? They may be pissed off, but they may not have an alternative. So you tend to find that systems which are B2C tend to have a higher criticality than systems which are B2B. Because when a B2C system is down, especially an online shop, like I said, they're losing tens of thousands, hundreds of thousands. That's the number they're using to calculate their downtime, right? Now we've started to talk about costs, we can actually start to look at these different strategies from a cost perspective, right? So praying doesn't have much of a cost associated to it, right? And we can start calculating the RPO and RTO for each stage that we've done so far. So, if your strategy is praying, then all I can say is good luck, right? You can't really calculate that. When you're doing just a standard backup and restore, then you might be thinking, especially when you're just doing a backup maybe once per day or whatever, you might be calculating this in terms of weeks and days. And that really depends on how good your strategy is for backups. Like, for example, let's say your servers go down, you may end up having to spend a lot of time reconfiguring your servers to actually become available again. Right? You might be down for a whole week, right? Depending on how sophisticated your backup and restore strategy is. Now, infrastructure as code, the ability to automate that infrastructure, really brings that down to hours or days, right? You may need to rerun your infrastructure as code scripts. You may need to then do a database restore. It all depends on the amount of data you have, how long that restore takes. Then when we start taking advantage of the cloud resilience functionality, usually you'll find that your RPO, RTO could be calculated in hours. Now, obviously, there's a good chance that the cloud providers may have made it that the incident didn't even affect you to begin with, but there will always be a calculation here of, what's the worst case scenario, because you never know. It could even be that the whole region inside of AWS goes down. That does happen. And when we start getting to enterprise, we start thinking of RPO and RTO from the range of milliseconds to minutes, and the cost balloons. And so when we start thinking of what enterprise does, we start paying already, the full price we're doing for startup, right? Just to get going. And the next stage we come to is what we call a pilot light. We'll come more to that in a moment. And usually we start defining the RPO or RTO in tens of minutes. Then we get to the concept of warm standby. And usually this means we start calculating this in minutes. And when we start getting to the big multi-site approach, we start calculating this in milliseconds, right? Or seconds. And to be honest with you, there's a lot of dollar signs down here. It could probably even go bigger than this. Depending on how much you want the resilient to be, there's enough money in the world to pay for it. And when you get to the multi-site approach, it's just like from the Dark Knight, it's not about the money, it's about building an infrastructure. So the first thing we do when we talk about enterprise is enterprise very rarely starts with implementation. Usually for enterprise, it's a lot more investigation on how much to actually invest in order to achieve something. The process for enterprise might look like this. So for the first stage, we identify critical systems and processes. And what this usually means is listing all business processes and their dependencies and putting them in different tiers. So you might have, for example, tier 1, which is systems directly tied to revenue and customer satisfaction. Tier 2, which might be operational systems like internal systems, reporting, things like this. And tier 3, which is things like non-essential tools like historical data and archival data. The first thing you do is you usually make an inventory of your whole system. Then we want to calculate the cost of downtime, which requires us to estimate the financial impact of each of those systems being down. Now, usually that means covering things like, now the first thing we want to do is we want to look at the revenue loss. So, how much revenue is lost per hour or whatever of the system being down. The next one would be checking the customer impact. What is the perceived perception of your customers for your system being down? Like, for example, when I'm using a banking app and the bank is down, I tend to get really annoyed at the bank and lose a lot of trust in the bank that I'm not able to access my own money. That's a huge customer reputational loss. And then you might have operational costs, right? You might have the cost of overtime for staff to fix the problem. You might have penalties, you might have compliance, legal, whatever it is, right? So that's the other third type of cost I would consider. So for example, if you have an e-commerce website and you make £10,000 an hour, then your downtime just on that alone for lost revenue, you could calculate as £10,000 an hour, right? And then you want to estimate the financial impact of data loss. And what you want to do is you want to look at how much data you would lose over a period of time and what that associated cost that data would be. For example, how much would it cost you to recreate that data? When I'm calculating this, one of the things I like to focus on is the loss of customer trust, because if you really think about it, you can usually try to pin a number to the reputational loss that you might receive from a client, right? The cost of a contract, for example. And now we've charted out the costs, we now want to define the acceptable RTO and RPO values. You might end up making a graph like the one I have down here, where we have, the system to criticality to RPO to RTO, and we define like in a nice chart, allowing us to see the whole system and be able to do a cost-benefit analysis of how we should continue, right? Because you might have different part of your systems requiring different levels of disaster recovery. So for example, let's say we do a cost-benefit analysis and we find out that our downtime is causing us the loss of, let's say, £10,000 an hour. And let's say we invest £50,000 into improving our system, then obviously, we'll break even if we have 5 hours of downtime in a year, or alternatively more than that. Now remember, whenever you invest in disaster recovery, it's not just the time to implement the solution, it also requires an exponential cost to maintain. There's a higher complexity with each level of disaster recovery we do, so there's more labor required to maintain it, and usually more costs to whatever provider you're using in order to pay for the more complexity that you're using. And then with all of these conversations, you always need a healthy balance of risk, right? We can never fully get rid of risk. And so there always has to be a healthy understanding of risk in your system. So let's talk about these strategies for enterprise. So we're going a bit further. The first one is pilot light. And what a pilot light is, if you've ever used one of the older gas heating systems, it's basically a light, a gas light, which is always a light. And so it's always continuously burning next to the main burners, which can be switched off and on depending on when you want your heating. And because there's always a small light, which is always on fire, when you turn on the main burners, they don't have to go through a manual process to relight them, click, 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 because there's always a fire right next to the main burners waiting for them to be turned on and the gas to be released. And so a pilot light, if you think about it, is a low-cost system which is always running, waiting until it's needed. But it is always running. So for example, let's say we have our system in one cloud region here. And this might mean that our system is distributed across multiple availability zones, right? So this is one step back of that cloud resilience approach I said before. And we're already on multiple availability zones, but we're on one region, right? So it might be we're in multiple data centers in Ireland, the Netherlands, or whatever. And you have the infrastructure as code ready to go for another region. And you've already provisioned all of the base resources in that region. So, for example, you've already provisioned the networking, you've already provisioned the database. That's all ready to go because databases tend to be slow to start up. You don't want to have anything which is slow to start up, not already running, right? So you already have your database already started up and it's already replicating your data to that database. You might even have a Kubernetes cluster, for example, already running here, but scaled down. So that means already having the master node provisioned inside of the cloud. There's nothing actually deployed in the system. Everything is just ready to go, waiting for deployment. And so when there is an outage on the main cloud region, we can then very quickly scale up everything on this other region to take the load from the original active region. And this is what's called an active-passive setup, right? Because we can see that this side is active and this side is passive. And so there is a higher cost from running this than what we talked about before, because you are paying money for, the resources which do have to be continuously running, like the networking resources or the database, but you're not paying a premium for running your applications in duplicate on another region. And so what this allows us to do is to enable a rapid disaster recovery process when, a whole region is down in that cloud provider. And the key metric to be focusing on when you're trying to improve this setup is to be able to detect the outage and the downtime as early as possible in a very concise way without false positives. That's very important. You can't cause false positives in your error detection method, or otherwise you're going to be moving from a healthy system to a healthy system unnecessarily and therefore causing downtime as it does the scale, So we need to have an error-prone free way, and it needs to be automated too, because if it is a manual process, then probably the manual people who tell you it's down are probably your customers. Probably that is at, 8 a.m. or 7 a.m. in the morning when people start logging in high demand, rather than say maybe 10 p.m. the night before when a fix could have been implemented quite easily. And it's just that you didn't have that automated system to tell you, right? So you had to wait for your customers to actually need the application right now in order to know the system was down. So then we start going to the next level of active passive, right? This is still active passive. We still have our main active region, and then we have our passive region. And the difference between warm standby and pilot is with pilot, we didn't actually have our applications running. With warm standby, you usually have your applications already running inside of the system. Now, they may be scaled down, right? They may not be at their full scale, but they are running in a way which can, to an extent, take production load, right? So, it may be that they can take production load, but it's not very stable, and it might be slow, then they scale up, but they can still take production load. And because of this, this has a much higher cost than a pilot-like setup, because, this could mean having to already provision the majority of your nodes for Kubernetes or whatever setup you're using inside of the cloud provider. And then with a warm standby method, if the main region goes down, like over here, the passive setup becomes active, and there's no immediate scaling up that is required in order to actually take the immediate load off the other environment. And so this usually brings your outage time, which is, common with pilot light for maybe, tens of minutes, waiting for everything to scale up, to literally being maybe a minute with warm standby. We just need to wait for the load balancer or whatever it is, the automated system to really kick in and notify us, triggering the process and taking over. Now, when we're ready to spend real bucks and make the cloud providers very happy, that's when we go for active-active. Active-active basically means that both regions are continuously used all the time anyway. And each one region is scaled up competently enough that it can handle the whole load of the whole system by itself. You're effectively duplicating two whole systems in their entirety, and they're running together. Now, the reason fundamentally why this costs so much more than an active-passive setup is your data layer tends to require to be a lot more sophisticated. Now, I've done this before for other companies, and usually you want to have a data layer which focuses on data partitioning, or alternatively, eventual consistency. So, for example, Cassandra or Kafka, inherently they have data partitioning, which means partitions of the same bit of data are stored on multiple servers at once, and it's all nicely segmented. So if one system goes down, then you don't lose a complete copy of all that data, right? Your data is fully distributed across the entire system. Or alternatively, like how S3 works inherently, it works with the concept of eventual consistency, which means while in one exact moment of time, the data between both systems is not comparable, they will eventually become comparable over time. And so in this example, when we have one of the main regions being down, you end up in a very simple situation where the load balancer just continues to forward the data to one of the systems that it already does forward the data to, and there's almost no conceivable downtime to the end user. This may be calculated in milliseconds to maybe even seconds, right? Depending on if you have persistent connections may need to be recreated. In this example, we're dealing with extremely low levels of downtime. And then when the other region does come up, you end up in a situation where, it starts copying back any pieces of data that those instances of the databases are missing, so that this region can become available again after, the data inside of a system has fully replicated being available for this whole region, right? So part of the downtime for this region will include waiting for that data to be made available fully again. So I hope you really enjoyed this video. It's a bit of a long one. I hope you guys are enjoying these long videos. I do like really trying to explain something in its entirety, even though I understand it might be a bit boring to listen to. But if you have any questions, please feel free to ask them in the comments. I'm always happy to help you guys out and to assist you in any way that is necessary. If you have any ideas of any other types of videos like this you want me to make, please let me know. I do want to continue to make more architectural-based videos for infrastructure engineering in general, because it's quite a complicated topic and we're dealing with very critical systems. So it's always important to make sure you think of these problems before they become a problem, rather than thinking of these problems during the problem, right? Which I can assure you, I've been there. So you don't want that. Thank you so much for checking out this video. If your organization is looking for any assistance to allow you to increase your maturity when it comes to disaster recovery, please feel free to reach out to me and I'll be happy to give you the help. As always, I hope you guys have a lovely day. Cheers.